Hi everyone. So today we're going to take a look at using trig for any angle. But before we do, I thought we could look at this bell work problem. Here I'll draw it nice and large. So we're here, and this is Mount Lemon. We're driving toward Mount Lemon. And the first time we pull over and look up at the mountains, the angle of elevation is 3.5 degrees. Okay? And the second time we pull over, we drive down the road a little more, 13 miles. And now we're here, and we look up at the top of the mountain, and this time the angle of elevation is 9 degrees. Don't know how far away we are from the base of the mountain, but what we really want to know is the height of the mountain. Okay? So, we've got right triangles here. And we'd like to use our knowledge of right triangles to help us figure this out. Okay, so what's that going to be? Well, here's what I notice. I notice that there's actually, that's right, two different colored triangles here. There's this small one in red with 9 degrees, X and H. And over here, we have this big one in green with 3.5 and H, again, same height on both of them. Now, this side is not just 13. This part is 13. This part is X. So the whole side is 13 plus X. Okay. Now, some of you may be saying, well, Mr. Google, how does that help me? Well, it helps you this way. Can you write me a trig equation for this picture? I think that would be great. That would be tangent of 9 degrees equals opposite over adjacent. And here, what equation could we write? Well, also tangent. And so I would say tangent of 3.5 degrees equals h over x plus 13. Okay, so I've got two equations and I've got two variables. This is a system. And in these systems, yeah, no, sorry, I'm not going to be doing elimination. I'm going to do substitution. I'm going to get both of these equations equal to h. And now that they're both equal to h, I can set this stuff equal to this. So I'll have x tangent 9 degrees equals, and these parentheses are really important here, x plus 13 tangent 3.5. Now, my goal is to get x equals. So how are we going to do that? Well, I'm going to distribute and have x tan 9 equals x tan 3.5 plus 13 tan 3.5. Get all the x stuff on one side. X tangent 9 minus x tangent 3.5 equals 13 tangent 3.5. Fabuloso. Now, I can't do the subtraction because these angles are different. But what I can do is factor out an x. And that'll leave me with tangent 9 minus tangent 3.5 equals 13 tangent 3.5. Good. How is all this stuff in parentheses attached to the x? With multiplication. So if I want to get x by itself, what am I going to have to do? That's right. I'm going to have to divide both sides by all this stuff in parentheses. Okay, oops. Tangent x tan 9. We're going to need this equation, but not that one. So x equals 13 tan 3.5 over tan 9 minus tan 3.5. So let's pull out our calculator. Remember, everything in the denominator has to be in parentheses. Like, I want to divide this by all of this stuff. So I'm going to have 13 tangent 3.5 divided by parentheses. Tangent 9, don't forget to close that parenthesis, minus tangent 3.5. Here, you not only have to close that parenthesis, but you need to close the one that covers everything in the denominator. Okay, what do we get? We get 8.178 miles. Well, that's great, except that's not our answer. Remember, we just solved for x. That's this. I want to know the height of the mountain. Well, luckily, we have this equation here. X tan 9 equals h. Oh, h is the thing I'm looking for. So let's take this number and plug it in for x. So I'm going to do 8.178 times tangent of 9. And I get that h equals 1.295 miles high. All right. Now, will you see that on the next assessment? No. But we are going to, in fact, we are going to, 2 or 3 units from now, maybe 2 units from now, we're going to be doing a word problem and scatter plot unit in Trig land, and that's going to be a common problem. So just wanted to sort of get you starting to think about, ooh, look, 2 triangles, and how you could solve that system. It really helps if you start thinking now about that. Okay, so let's move on. Now that you've done that, hey, yeah, when we look at Descartes' Cartesian plane, here's our quadrant 1, here's our quadrant 2, quadrant 3, and quadrant 4. Don't ask me why he numbered them like that. I'm not a French guy from the 1600s, sorry. But what I do want to notice is, in the first quadrants, all of the ordered pairs have positive x's and positive y's. In quadrant 2, I have negative x's and positive y's. In quadrant 3, both the x's and y's are negative. And in quadrant 4, the x's are positive, but the y's are negative. Now, with that in mind, I kind of want to know which trig functions are positive. No. In what quadrants? In what quadrant is trig function positive? And what do I mean by that? Well, remember that all of them are positive here, because both the x and the y, and since tangent is y over x, plus over plus equals plus, all are trig functions are positive here in first quadrant. But over here in second quadrant, the x value is negative, and therefore cosine is going to be negative here. And since tangent is the y value over the x value, positive divided by negative, no, that's not positive. So tangent isn't positive, cosine isn't positive, but because the y value is positive, we know that sine will be positive in second quadrant. What about third quadrant? Who's positive there? Well, not sine, not cosine, but tangent is positive over here. And fourth quadrant, well, I see the x value is positive, and so that tells me that cosine is positive here in quadrant 4. So what I have here is a tidy little understanding of the only thing that's going to be positive here is sine, and the only thing that's going to be positive here is tangent, and the only thing that's going to be positive here is cosine. And we have a little way to remember that. All students take calculus. All students take calculus. Okay? All right, now what's that for? Well, I want to have another round of what's my quadrant? What's my quadrant? So if sine of theta is less than 0 and cosine of theta is less than 0, what's my quadrant? Where does theta live? In what quadrant do we find theta? Well, we've done these before. I'll warm you up with this one. Sine, the y value, is negative. Well, the y values are negative down here. Great. Cosine, that's the x value. Cosine is negative over here. Where do these two overlap? Here in quadrant 3. Theta is in quadrant 3. That's what we're looking to do here, okay? All right, so now it's your turn. Sine of theta is greater than 0, but cosine of theta is less than 0. In what quadrant does theta live? Okay. So, did you say, hey, sine is positive in these quadrants, and cosine is negative in these quadrants, and say theta is in quadrant 2? That's my answer. Okay. C. C is secant theta is greater than 0, and cotangent theta is less than 0. I'm going to give you a minute to think about that. So, I know that secant is the reciprocal of cosine. Great. So 1 over cosine is positive. Well, that's the same as cosine being positive. Cosine is positive here. So 1 over a positive number, yeah, still going to be positive. And cosine is positive here. Those x values are positive. And 1 divided by that positive cosine value is still going to be positive. So secant is positive in 1 and 4. What about cotangent? Cotangent is less than 0. In order for cotangent, which is cosine over sine, to be negative, that means that one of these is negative. Okay, so here's the place where the cosine is negative and the sine is positive. And if we make the cosine positive and the sign negative, we'd be talking about over here in fourth quadrant. Tangent and cotangent are positive here. Tangent and cotangent are negative here. And our overlap with secant theta is greater than 0. That's fourth quadrant. Quadrant 4 is my answer to this problem. How about this one? Cosecant theta is less than 0, and secant theta is greater than 0. So this is the reciprocal of sine, and so I'm asking, when are the sine values negative? Sine values are negative here. Secant, that's the reciprocal of cosine. I'm wondering when cosine values are positive. And I overlap in theta is in quadrant 4. Okay? Excellent. We're done with, yeah, all right, I'll do one more. How about cosine theta is less than 0 and tangent theta is less than 0? In what quadrant do I live? But this is the last one. We need to move on. Okay, so cosine is negative. That's the x values are negative. Tangent is negative. In order for tangent to be negative, we need to have either a negative over a positive or a positive over a negative. So where do we find sine and cosine, or x and y values, with opposite SIGNs? Well, here, sine and cosine are positive. And here, sine and cosine are both negative. I'm looking for they have different SIGNs. And that happens here in fourth quadrant, where cosine is positive and sine is negative, and here in second quadrant, when cosine is negative and sine is positive. So the overlap is here. Theta is in quadrant 2. Okay, let's move on. These next problems say the terminal side of the angle passes through the given point. Find cosecant theta. And the given point that they give us for this problem, -3, -4. So, terminal side, yeah, I talked about it on the first day in this unit. We said that this was the initial side, and wherever the angle ends up taking us to, this is the terminal side. And what I know is that this terminal side passes through the point -3, -4. Okay, so I know that this is -3 and this is -4. The x value, the y value, the overness, the upness, or in this case, downness. And we're asked to find cosecant. Well, I know that cosecant theta is hypotenuse over opposite. I can't use the fact that cosecant is 1 over y. That only works on the unit circle. When we're not on the unit circle, and I know we're not on the unit circle because we can't have any values bigger than 1. Bigger than 1 or smaller than -1. And these are definitely smaller than -1. So what do I need in order to find cosecant? I need the opposite side. There it is, -4. I also need the hypotenuse. So how can I find that? Well, that's right. I can use Pythagorean theorem here. Or, good, you remember that there's a Pythagorean triple, 3, 4, 5. So either we're going to use the Pythagorean theorem to find that this length is 5, or we're going to recognize the triple. And so we want hypotenuse, cosecant theta is hypotenuse, over opposite. There we go. That's not so bad. So what if instead we said that the point that the terminal side passed through was 5, negative 12, and this time we're looking for secant theta. Find secant theta. Well, I agree. I want to draw this triangle where the x value is 5 and the y value is negative 12. My angle is this angle. I'm passing through that point, 5, negative 12. So, what's secant in this picture? Well, secant is 1 over cosine, and so I need hypotenuse over adjacent. We don't know how long the hypotenuse is, though. Again, it's a right triangle in this unit, so I could either use the Pythagorean theorem, 5 squared plus negative 12 squared equals hypotenuse squared. 25 plus 144 is hypotenuse squared. 169 equals hypotenuse squared. And when we take the square root of each side, we see 13. I can do this with the Pythagorean theorem. I find it easier to recognize the triple. 5, 12, 13. In the last problem, we saw 3, 4, 5. We also know that there's 8, 15, 17, and 7, 24, 25. Not 6, 25. So these are called our primitive triples, and of course multiples of these work as well. So, how about this one? What if we're passing through the point negative 8, 15, and we're looking for tangent of theta? Okay, not a problem. I'm going to use that magic secret of trigonometry, and I'm going to draw a triangle where the x value is negative 8 and the y value is positive 15. Negative 8, positive 15, and so there we are. Okay, the tangent is what here? Well, I don't really need to do that. I don't have to find that because tangent is opposite over adjacent. Tangent theta equals 15 over negative 8. Ta-da! So, when in doubt, draw a triangle. Now, there's a variation on that type of problem. It looks like this. Cosine theta equals 8 over 17. Now, why can't I just draw this triangle? Well, the reason I can't just draw this triangle is cosine is positive both in first and fourth quadrant. And so I don't actually know what quadrant to draw the triangle in. Oh, but wait, there's a second piece of information here. Tangent of theta is less than 0. Well, I know in first quadrant, tangent is positive. All of them are positive. All students take calculus. Okay, so tangent is positive in 1 and 3, and tangent is negative in 2 and 4. Okay, tangent is negative in 2 and 4. Cosine is positive in 1 or 4. So where do I draw my triangle? I draw it in fourth quadrant. And that actually kind of matters because people make all kinds of SIGN mistakes because they don't actually draw the triangle where it belongs. You know, they just say, here's my triangle. And so they say, oh, okay, so this is going to be 8 and 17. And they say, oh, that must be 15. Yeah, so guess what? That's not going to be our answer, is it? If they ask me for, hey, what's the sine of theta? I'm going to say opposite over, and I'm going to say that that's going to be 15 over 17. And then teacher's going to mark it wrong. How come? Because I have to be in this quadrant. Okay, so let's draw the triangle there. Okay, theta, I still have 17, I still have 8. This is negative 15. And sine is opposite over hypotenuse. Sine of theta is negative 15 over 17. So the student may know how to draw a triangle, how to label some sides, how to find the sine in this picture, and still get the problem wrong because they're not thinking first what quadrant to draw the triangle. That needs to happen first. Figure out which quadrant based on the constraints you've been given, and then draw and label your appropriate triangle, not this one, because that's where these two facts overlap for us. Okay, I can deal with that. And in this case, we were looking for, did we find the thing? Yes, we found some. Good. So how about this? Your turn. I know that tangent theta is negative 12 over 9, and I know that sine of theta is greater than 0. So, can you tell me what secant theta is? Excellent. I just want to know secant theta. Give it a try. Come back when you're done. Nice. So, did you draw a triangle? Now, in what quadrant did you draw it? Tangent is negative here and here. Sine is positive here and here. So I need to draw a second quadrant triangle. So my second quadrant triangle. Hey, I want to say something about this. Here's my second quadrant triangle. But some students draw this triangle. These students, they get these problems wrong every time. These students get the problems right every time. And so what I want to say for all these draw a triangle problems that you're going to be playing with, I want to say you always draw this line to the x-axis and never draw the line to the y-axis. So if I had something down here in third quadrant, to the x-axis, or here in fourth quadrant, to the, here's my angle, and then I go to the x-axis. I never draw to the y-axis. Okay, so we know tangent is negative, sine is positive, so we're drawing the second quadrant triangle. The tangent is, well, wait a second, how can that be negative 12? And the answer is, in middle school, your math teacher tried to get you to understand that this is the same as that is the same as that. And you know what you said and what you thought? You said and you thought, that's obvious. Why do I need to even spend time thinking about that? Because of this right here, right now. Opposite can't be negative in this quadrant. Only in this quadrant could my opposite be negative 12 and my adjacent be 9. So I'm not going to, even though that's been presented to me, opposite is 12, adjacent is negative 9, and we're looking for secant. Well, I know that secant theta is hypotenuse over adjacent. Well, I've got the adjacent side, but I don't have the hypotenuse. How am I going to find that? I mean, I can tell you it's 15 because I know my Pythagorean triples. This is negative 3 times 3. This is 3 times 4. And this is the one that we're looking for. I don't know what that is. Well, I've got 3, 4, and that triple is 3, 4, 5. But since each of these are multiplied by 3, this has to be multiplied by 3, which is why I know that's 15. So, hypotenuse, 15, adjacent side, negative 9. You could, of course, simplify that to be negative 5/3, and that's what secant theta is going to be. Okay? All right. How about this one? And this one, instead of finding one trig function, we write down all 6. Secant theta is less than 0. Cotangent theta is great. Is going to be a number 24 over 7. Okay, so A, figure out what quadrant to draw this triangle. B, draw and label the triangle with these appropriate pieces of information. And then C, find out what the sine of theta and the cosine of theta and the tangent of theta and the secant of theta and cosecant of theta, and we know the cotangent of theta is 24 over 7. All right, so I need you to find these, and the easiest way to do that is to draw a triangle, and you got to pay attention to what quadrant to draw that triangle in. What quadrant are you going to draw that triangle in? Well, I hope that you're going to draw this triangle in secant is negative, so when is cosine negative over here? Cotangent and tangent are positive in this quadrant and this quadrant. Aha! I need to be drawing a triangle in third quadrant. Always the x-axis, never go over here to the y. We know that cotangent, which is adjacent over opposite. Well, wait a second. In third quadrant, these are negative numbers. And that's really important. We can use Pythagorean theorem or Pythagorean triples to find out that this is 25. And so here's the thing. Like, this says 24 and 7. So I write down 24 and 7. And so I come over here and I say 7 over 25. Because the hypotenuse is 25, and I get that problem wrong. How come? Because in this quadrant, these values have to be negative numbers. And a negative divided by a negative is going to be this positive thing. So please, pay attention to things like that. I noticed that most of the mistakes that happen on this next assessment is because people aren't actually paying attention to details like that. So once I've got this picture in the right quadrant labeled properly, it's no problem for me to say that the cosine of theta is going to be negative 24 over 25. Tangent theta is just the reciprocal of cotangent, so that's 7 over 24. Secant, that's the reciprocal of cosine, so 25 over 24. And cosecant, well, we know that cosecant is the reciprocal of sine. So we've got negative 7 over 25. Fabulous. I think it's your turn to do one of those, don't you? Oh, no, it isn't. But you will. You'll get more practice with that. You definitely want to be comfortable with that. There's 2 last topics I want to look at with you today. This one, they tell us that y equals 1/3 x. And in quadrant 3. Huh? Yeah. So, humor me. This is what they want us to do. They want us to draw a triangle in quadrant 3 where this hypotenuse, or it's just the terminal side of the angle where the hypotenuse is on this line, y equals 1/3 x. And surely 1/3 x, no problem. Hey, isn't that the slope? Isn't slope rise over run? So I'm going to go over 3 and up 1. Oh, except over here, I'm going to go down 1 and backwards 3. They told me I was in quadrant 3, and so I needed to use this slope to help figure out what the x and y values were. I had 1/3, right? Positive slope. Change in y's over change in x's. Change in x's is 3. Change in y's is 1. Fabulous. 1/3. Except that because we're here, this has to be a -1 and this has to be a -3. Okay, we've done that, so tell me, what's the sine of theta? Well, sine of theta is opposite over, oh no, I don't know the hypotenuse. How am I going to find that? Well, finally, we've come across a problem that does not use Pythagorean triples. So I'm going to have to find the hypotenuse. Okay, I get that h squared equals 1 plus 9, h squared equals 10, and h equals square root of 10. So I know that my hypotenuse is square root of 10, and if I'm looking for sine, it's just opposite over hypotenuse. It's fine if you leave this unrationalized. I noticed that most people prefer this. Good. So, what if I was asking not for sine of theta, but for secant of theta? Well, remember, secant is hypotenuse over adjacent. And so for us, the hypotenuse is √10, and the adjacent is -3. Okay, how about you do this one? Same thing, where that hypotenuse lives on the line. 4x plus 3y equals 0, and we're talking about quadrant 4. Okay. What do you mean you're stuck? Well, but we did it in the last problem. Yeah. Don't let the fact that the form looks a little different dissuade you from thinking you can do this. You can do this. Same. It's an equation of a line. So let's graph that equation of a line. It's got a negative slope, and we go down 4. We go down 4 and over 3. Oh, look, 3, 4, I guess that's 5. It doesn't work for any 3 consecutive numbers. There's no such thing as the 2, 3, 4 right triangle. But there is the 3, 4, 5. But there is not the 4, 5, 6. So it's not any consecutive numbers. It's just these particular ones. Oh, there are actually an infinite number of solutions to the Pythagorean theorem. So in this situation, we've drawn our hypotenuse along the line 4x plus 3y equals 0. And we're asked to then find all the trig function values. Or how about we do cosine and cotangent? What's the cosine going to be here? So the cosine here is going to be adjacent over hypotenuse. And that makes sense because in fourth quadrant, cosine is positive. All students take Calculus, cosine is positive in fourth quadrant. Cotangent, well, cotangent is positive in these quadrants. Cotangent is negative in these quadrants. So what's cotangent? Cotangent is adjacent over opposite. And for us, that's 3 over negative 4. All right. Hey, notice that this is the reciprocal of that because the slope is our tangent value. Slope is tangent. Okay, so there's one last topic here that I want to talk about. And this is a really old school topic. Yeah, it's a really old school topic, and I really don't want to spend a lot of time on it because I don't think you're going to see it. But when I was a kid in geometry in high school, we used reference angles all the time. Yes, I will admit I'm old enough that I saw when this was first introduced to math, and it was long after I was in a math class in high school. What I want to say is it used to be that we would have these things called trig tables, and they used to be like, oh my goodness, the real chunk of your book would be these trig tables so that you could look things up. Like you could look up the sine of 23 degrees. Well, so publishers of these books said, whoa, these books are going to be terribly expensive if we have to send out all these trig tables in all these books. Couldn't we narrow it down instead of 0 to 2 pi radians for every, incremental radian bit there to 4 decimal places? Oh my goodness, no, but really, you could actually buy a book of trig tables. And so that was terribly expensive. And so what publishers and math teachers hit on was, well, we'll teach kids how to use first quadrant to help them find second, third, and fourth quadrant. No kidding. And that uses reference angles. Okay? So a reference angle over here in second quadrant, I'm looking for this one. This is my theta, but I'm using this one, theta prime. A reference angle is an acute angle. Smaller than pi over 2 or smaller than 90 degrees. Like this angle here. This angle is bigger than 90 degrees. This angle is bigger than pi over 2. And so the textbook publishers wouldn't help us with that. No, sorry. But they would give us information on acute angles, on angles that live in first quadrant. And so what you would do is say, okay, well, that's like this one. This first quadrant angle, except I'm going to have to pay attention and make sure that when I do this problem, even though I've used this angle here, that I'm going to turn this into a negative, because it used to be positive when I do it over here. I know, this is like really complicated stuff. And so what we would say is something like this. If I have this 150 degree angle, well, no, I'm going to use this angle, which is 30 degrees. So how can I find theta prime? Well, in quadrant 2, theta prime plus theta should add up to pi, or 180. Okay, so I know that theta is 150, and I'm looking for theta prime, and so if I subtract 150, I get that theta prime equals 30. And you could say, you could just go right to the place where you say, okay, the rule for reference angles here is that theta prime is going to be pi minus theta, right? I'm going to subtract this pi minus theta to get theta prime away. Or theta prime is 180 degrees minus theta. And so we could find our first quadrant reference angle. Okay, cool, I could do that, but that's only for quadrant 2. Down here in quadrant 3, if I've got this angle, this is my theta, well, this acute angle here is theta prime. And I want an acute angle because that's in first quadrant, and therefore I can use the trig table in the back of my book, which goes from 0 to 90 degrees. Yeah. So what about here? Do these rules still work? Well, let's imagine that this angle is 210 degrees. Okay? 210 degrees. If I do 180 minus 210, I get negative 30. And I know my angle is supposed to be a positive angle between 0 and 90. I'm looking for an acute angle, definitely not a negative angle. So the rules aren't the same. Here, what we're going to say is that theta minus pi equals theta prime, or theta minus 180 degrees is theta prime. So that if I had 210 and I subtracted 180, I could get that theta prime equals positive 30 degrees. Oh, well, that's wonderful. So I've got a different formula here for figuring out reference angles in this quadrant. Theta prime is going to be theta minus pi, or theta prime is going to be theta minus 180 degrees. Guess what? Still different formulas over here. So in this situation, let's say I have this angle here. That is 300 degrees. Okay, there's my theta. But I'm going to use this acute angle, theta prime, instead. And here, I just have to change the sign on the y value. Fabulous. So this is 300 degrees. How big is that angle? Well, that angle has to be 60. And how did I do it? I said that theta prime should be equal to 2 pi minus theta, or theta prime equals 360 minus theta. So if I do 360 minus 300, that's our theta, I end up with theta prime is 60 degrees. So my reference angle is 60. But look, really, no. I mean, no. This has the whole book of trig tables in it. No, we don't need to do this anymore. Now, this may be one of those times where, like, not enough old math people have died yet, where we still need you to be aware of this. So I don't plan on asking you, and you should ask Mr. Paz if he plans on asking you about finding reference angles. Okay? All right. Now, yeah, because I don't know. Because look, you've got, and they're all different. And look, if you're dyslexic like me, you're always screwing these up. So, no. And why are there none here? Because a reference angle is an acute angle. So if I'm in here, the angle I got is the angle I'm using. Yeah. Now, why spend any time talking about this at all if really it's old school? Well, the answer to that question is a little more complicated. In a little while, when we do inverse trig graphs and solving equations, trig equations, using a technique like, but not, reference angles will help us. And so showing you how I could find this acute angle by using this recipe, or finding the acute angle here by using this recipe, that's actually going to position you well for when we need to do that other stuff, which is still very current and still very important. This reference angle, oh, you're going to suffer so much. I mean, I'll show it to you. Here, look. Theta is 7 pi over 4. Okay, but, that's bigger than 0 to pi over 2. This is This is a fourth quadrant angle. So I'm looking for an acute angle that behaves like that one. Well, we said in fourth quadrant, the way we're going to find theta prime is to subtract theta from 2 pi. Well, there's my theta. And so I have 8 pi over 4 minus 7 pi over 4. It's pi over 4. Theta prime, the reference angle, is pi over 4. And yeah, pi over 4, pi over 4. Here's that 7 pi over 4. So instead of using all of this rotation, I'm just saying, well, look, I could just use this acute reference angle, and then whenever sine came up in one of my questions, I would just make sure I put in a negative number. Yeah, I don't even like talking about it. Yeah, in fact, I'm not gonna. Well, that's it then for us for today. I think we've only got one more section to look at before we start reviewing for our assessment. So I'll see you in that last video, and I hope you have a fabulous day, everyone. Take care.